This is video tutorial number 2 for chapter 3. So in this video, we will be solving trigonometric equations involving the reciprocal ratios. So this equation that we are solving for involves secant. So we have to solve 3 times secant x minus 4 equals to 0. And the values of x that we should get should be within this range of values of x. So from 0 to 2 pi. So that means x is in radian because the angles, x represent angle, and it's given in terms of pi. So how do we solve for the values of x? So this equation should be simplified first. How do we simplify it? We need to make it in the form trigonometric ratio here equals the ratio. Okay. So from this, we will now have secant x is equal to 4 over 3. Okay. Notice how we got that from the original equation. So this is what we mean when we say the format should be like this. The ratio, the name of the trigonometric ratio, the angle, is equal to the ratio. This is the ratio 4 over 3. Since secant is a reciprocal ratio, we need to remember that this is the reciprocal of cosine. So that means cosine x is equal to 3 over 4 because they are reciprocals. Why do we need to change secant to cosine? Because our calculator, which we will use later to solve for the value of x, only has sine, cosine, and tangent. It doesn't have secant function. Okay. So here, we are now ready to get the value of x. From here, we find the basic angle first. The basic angle for x. How do we find the basic angle for x? Shift cosine of 3 over 4. We will use our calculator to get this value. And we have to make sure that the calculator is in radian mode. So look at the screen. There's a D there. Right now on my calculator screen, it's a D. So it's in degree mode. So I need to change it to radian mode. Shift mode 4. Okay, now it's an R. So we can now get the value of the basic angle for x. So shift cosine 3 divided by 4. And that is this value. I will round it off to 4 significant figures because later on the final answer will be in 3 significant figures. So that will be 0.7227. 4 significant figures. 1, 2, 3, 4. Okay. This is not yet the value of x that we need. This is the basic angle, which we will use to find all the possible values of x that will satisfy this equation. So how do we find those? 0 to 2 pi. And cosine is positive. So we need to remember in which quadrants is cosine positive. It's in quadrants 1 and 4. 1 and 4. So our answers will come from quadrants 1 and 4. Okay. It's easier if we draw the coordinate plane for quadrants 1 and 4. So we will be using this right angled triangle from quadrant 1 and this right angled triangle from quadrant 4. So this angle that we got here, the basic angle means the size of this angle with respect to the x-axis. And this one also. So this is 0.7227. Same with this, 0.7227. 0 to 2 pi. So we need to consider that the value should be within this range. So the first angle, positive. These values are positive, so our rotation will be going that way. Going anti-clockwise. Okay. So this is the first angle we will take from quadrant 1, which is 0.72. Round it off to 3 significant figures, so 3. The next angle will come from quadrant 4. Again, this is 0. The positive x-axis is your 0 radian. So that means we take this angle right here. And this angle is 2 pi minus the basic angle, which is 0.7227. Using our calculator, that will be 2 pi minus 0.7227. We round it off to 3 significant figures, 5.56. So 5.56. 5.56 is less than 2 pi. As we can see in our calculation, it's 2 pi minus. Yeah. So it's these two values are within this values of x. Now, can we go a second turn, which mean this angle? No, not anymore, because that will be more than 2 pi. Which means for this equation, we have found two values of x. Correct to 3 significant figures, 0.723 radian and 5.56 radians. So these are the values of x for this equation.